Um, Hello. Today I'm presenting my project, benchmarking conditional realism and synthetic limit order book data. So this work extends the lob bench framework with a new time-aware evaluation module to better diagnose quality of generated financial data. So what is a limit order book? A limit order book, or LOB, captures the real-time supply and demand of financial assets. So at any given moment, we have like our best bid price, which is the highest buy offer, and then the best ask price, which is the lowest sell offer. So as orders arrive, cancel, and execute, the state of the book like evolves as like as like a high frequency sequence, which presents a challenge modeling because the data isn't stationary. It's heavy-tailed and influenced by like strategic behavior from market participants. So why why synthetic lob data? Synthetic lob data is valuable for several reasons. So we can stress test trading algorithms, develop new research models, and share data without like revealing sensitive order flow. However, the synthetic data is only useful if it's actually realistic, and measuring realism is actually like really difficult. So the evaluation problems, right? Traditionally, people relied on visual comparisons, like stylized facts or like next token loss from language models. But these approaches like break down like over like longer sequences because they actually ignore like drift. So in another way, you could say that the generator might look fine early in a sequence, but it slowly degrades as like the errors accumulate. So we need a better way to quantify realism across time. So introduce you to LogBench. So LogBench provides a standardized approach. It maps like the raw limit order book streams into like interpretable like one-dimensional stats, right? So things like spread, order, imbalance, interval, inner arrival time, and it compares like the distribution of like real versus synthetic data using like metrics like L1 and Wasserstein distance. The benchmark also like supports like conditional scoring, discriminatory tests, and market impact measures to like detect what the authors also call like model derailment, which when realism like decreases of like as the sampling unfold. In this project, we reproduced the GitHub repository functionality and introduce like a new conditional evaluation module. So the goal was to see like whether the time of day segments provide like any additional like diagnostic value beyond in a single aggregated score. We expected like unconditional results to hide certain realism failures that become like obvious when broken into like trading regimes. So for our setup, we used Lobster Limit Order Book data from Amazon and Apple from 2000, June 21st, 2012. Our implementation computed three statistics, so spread, order imbalance, and arrival time. Then we constructed a simple synthetic generator using like some noise and some scaling so that distortions could be a little bit more clear and interpretable. And all the work was done on Python 3.11. We used NumPy, Pandas, Skippy, and Matplotlib. Here we see the L1 metrics. Spread has an L1 distance of 0.0609 and inner arrival time of 0.0405, suggesting our synthetic generator did a reasonable job matching the distribution shape. But however, like the imbalance is a significantly worse at 0.6889. Uh, this means the synthetic data actually failed to reduce the book pressure behavior, which is already a known challenge in generative financial modeling. These baseline results look actually acceptable at first, especially for spread and timing. But to go further, we segmented the training day from 9:30 a.m. to 4 p.m., which into like six equal time buckets. So for each bucket, we computed a weighted per bucket L1 score. So now the spread has a conditional L1 of 0.1032, which is actually noticeably worse than the unconditional value. Imbalance remains poor at 0.7014, and inner arrival time stays pretty stable at around 0.041. But the key insight is like the split in the day amplifies the visible drift. So the bar chart illustrates like where realism breaks down, right? So in real markets, spreads are like wide at market open because of the volatility. tight and it tightens around like the midday and when trading is like a little bit more calm and then widen around like near the close of the market. So the synthetic generator completely missed the tightening, this tightening like and widening pattern. Buckets late in the day show like very high L1 distances, which confirm the temporal mismatch that we're searching for. So the experiment shows that unconditional metrics understate like the realism problem. So a single like global L1 value might look acceptable, but per bucket analysis shows that the model consistently failed in specific time regimes, right? So this supports the original like motivation behind lob bench. Realism is not uniform throughout the trading day. We need a way to evaluate performance where it fails, not just where it succeeds, right? But there are limitations to note. First, like our synthetic generator was very simple. It did not like model dynamics or regime switches. We also only considered 1 day of data in equal time segmentation. So a more sophisticated strategy would be like such as volume volatility, like may like provide a better insight. But for feature extensions, it could include like testing more models such as transformers or GON-based generators using Marshall's time distance in addition to L1, and integrating like discriminator-based realism scores, which and another like natural extension to evaluate multiple stocks and multiple days to identify like systematic as well as asset-specific drifts.